Good afternoon, everyone. Thank you all for joining us for the energy reduction in non-domestic buildings session. We have a lot of content to get through from our three esteemed speakers, so let's get straight into it. I'm going to warm things up with 5 minutes on what I do at the UK Green Building Council, and then I'm going to throw to the speakers to share their work around energy reduction in non-domestic buildings. So my name is Carl Desai. I'm the projects manager for the Advancing Net Zero at the Advancing Net Zero program at the UK Green Building Council. Who the UK Green Building Council are? Well, we are an industry-led network with a mission to radically improve the sustainability of the built environment. And our power is in convening stakeholders from across the building value chain to work together in industry-led outcomes. This is a photo last year taken outside our offices where we gathered together about 400 of our members from the built environment to strike as part of the global climate strike. So just to set the scene, cast your minds back to 2015 when we were all rejoicing. It was a golden era. We'd struck multilateral agreement around achieving net zero emissions by around mid-century, and we were all aligned on this target. Unfortunately, the narrative since then hasn't been in line with those initial ambitions, and as we can see from that black line, emissions have been increasing year on year since 2015. And so we have a lot of work to do between now and 2050 if we are to avoid the most catastrophic effects of climate change, which are those lines shown with a steep trajectory to decreasing. The IPCC's latest report indicates that we need to reduce emissions by half by 2030. Which is no easy challenge. It's a similar kind of narrative in the built environment. We design buildings with modelled extremely high performance. However, in reality, they are far from their desired outcomes. Here we can see the performance gap where EPC ratings are not in fact representative of actual in-use performance. So this is an issue that we'll be coming back to through the speakers' presentations. What I thought I'd do was just to map out some of the market mechanisms that are currently out there and what they're doing to actually drive energy reductions in the non-domestic building sector. So starting from the bottom left, EPCs, not that reliable, modelled outcomes, not actually representative of actual in-use performance. Building regulations, exclusive of unregulated loads, BREEAM design, again, modelled outcomes, BREEAM in use. DEC is quite a good mechanism for understanding in-use performance and then using that for the owners to drive down energy use. What we've done at the UK GBC is develop a definition for what net zero carbon buildings is, and I'm going to get onto that later. And then we have a few initiatives at the kind of portfolio level, which is also helping to drive down energy reductions in non-domestic buildings. The one at the top right there is the World GBC's net zero carbon buildings commitment, and that's a commitment to achieve net zero emissions by 2030. That's an absolute target, so it does require an energy action plan to reduce your energy use. So what we do at the UK GBC is we're advocating for net zero buildings, and what that means is that by 2030, we believe that all new buildings should be designed to be net zero carbon, net zero and operational carbon, and by 2050, all existing buildings will need to be net zero carbon for their operational energy use. And at bottom right, you can see that hierarchy of energy reduction being the first tier to achieve that. So what we did is we took away those broad principles and we developed a framework definition for net zero carbon buildings specific to the UK market. And there were three overarching principles which drove the development of the framework. The first is to improve measurement and transparency, so to only talk about in-use performance and leave model performance behind. The second was to require the polluter to pay. So a tenant or a landlord or a portfolio owner can all demonstrate that they're net zero carbon for those varying scopes of energy usage. The third is to encourage action today because we no longer have time to wait. So we developed quite a flexible framework, and the intention is to develop that framework over the coming months and years to tighten requirements. This is the framework in a nutshell. The items in blue on the left are talking about embodied carbon, and obviously there's a tension between embodied carbon and operational carbon when we are looking at retrofit and new buildings. That's something that I'd like to ask speakers to potentially touch on, that tension between embodied carbon when you're undertaking a retrofit versus the operational energy improvements and how you might negotiate those two scopes of carbon. And what we're here today to do is to talk about the operational energy use and the fact that we need to significantly reduce the energy demand from our buildings in order to achieve net zero. Just to illustrate that a bit further, so we did an exercise in partnership with Better Buildings Partnership and British Property Federation, where we actually undertook a study to understand if we are to achieve net zero emissions by 2050, that means all energy use from the entire economy will need to be sourced from zero carbon supplies. And effectively what that means is we'll need to reduce our current energy demand significantly. So that orange line shown on slide is the increase in renewable energy over time. The purple line is the reduction in energy demand required across the economy in order to meet that sweet spot where total energy demand is supplied from 100% low carbon energy supply. And what we feel is that the building sector is going to need to be responsible for those energy reductions because it is very easy to decarbonize and reduce energy use in the building sector. So we've mapped that out for the office sector, and what this shows is a trajectory on what the typical energy use should be for office buildings between now and 2035 in order to achieve that net zero economy by 2050. So that's just a bit to set the scene. A few kind of questions peppered in there for the speakers. One around embodied carbon and operational carbon, how that might play out. The second around in-use performance and how we can work to use that as a primary metric for driving down energy use rather than modelled outcomes. So I'd like to welcome up our first speaker, Stephen Price, who's Business Development Director at Arbenco, who's going to talk about understanding energy with a digital building twin and the role of AI and virtual modelling in reducing energy consumption. Stephen?
Can I have the clicker? Thank you, Carl. Good afternoon, everybody. My name is Stephen Price, Business Development Director with Arbenco, and thank you very much, Carl, for that introduction. I'm going to talk about a couple of real case examples where we've been able to reduce the carbon and energy intensity of real non-domestic buildings over the last couple of years. And following on from some of the points that Carl has mentioned, I'm going to be able to demonstrate exactly how we've supported our clients to achieve that. So firstly, a little bit about Arbenco. Arbenco is a software house, a small company based in Glasgow. We specialize in environmental sustainability in the built environment. So we have software solutions for energy efficiency, for energy modeling, and for internal air quality, environmental quality for health and well-being. So, moving on to the subject in hand. I've described this as a digital building twin, but rather than some of the conversations that you'll hear around the show over the last couple of days, rather than formal BIM or digital twin and so on, I want to demonstrate a couple of mechanisms for the retrofit of existing non-domestic building stock and what we can do with the information that we already have that is genuinely digital modeling of our built environment and how we can use that to reduce the energy consumption. So the two types of energy modeling that I'm talking about is actually the SBEM model in the first instance. SBEM stands for a simplified building energy model, and that is exactly what it is, and we can use that to derive energy efficiency improvements for commercial buildings. The second type of energy modeling, rather than a digital twin, I'm going to model from a consumption. So we can use the consumption of the building to reverse engineer to identify where wastage and improvement can be made. So firstly, SBEM, for those of you that may not be familiar, SBEM drives the commercial EPCs. We have 1 million commercial EPCs in the UK at the moment. That data stock already exists, and there is a considerable value in that data stock. That building model contains information about the building shape, the size, the construction, the U values of those elements. It contains lots of information and data about the heating, the fuel, the HVAC, the boiler efficiencies. All of that data exists within the model. It contains all of the information about the lighting, the type of lighting, the type of lamp, the lumens, the efficacy across the zones and the operating zones within that building. And finally, it contains some information about the auxiliary plant engaged within the building. Now, based on that data, if that's what we know, what can we do with it? Well, using some smart software, we can take that energy model and we can model improvements. That's exactly what a digital twin can be used for, simulating improvements on the building. So for the building fabric, we can model the impact of changes to insulation levels, changes to those U values across the construction elements. For heating and cooling, we can model fuel change, we can model boiler efficiency upgrades. For lighting, we can model a retrofit installation and better controls. And for the plant and equipment, we can even model the feasibility of installing low-carbon solutions such as PV and so on. Take all of those together. Now I'm going to move into a couple of case studies. So these are real examples where we have been able to model these and demonstrate tangible improvements over the last year or two. So the first example I'm going to describe is actually a large retail unit in the north of England. Now, this is going to be part of a wider case study, and I don't have commercial permission to publish the details yet, but that will be coming. So at the moment, I have an anonymized example. This is a real example. So the EPC was undertaken in 2016. It is a good quality model. We've checked the data. We modeled it within Arbon Estates, one of our software platforms, and generated from that a full list of potential improvement measures across this building. The client chose to install a range of lighting upgrades, a full lighting upgrade, including some control measures, and changes to the air handling units and the drives on those air handling units. And that combination of measures was simulated to deliver a potential 34.5% improvement in the energy consumption, a reduction in energy and carbon for that building. Now, before they undertook that installation, this was in August of last year, we took a baseline of the previous 12 months or more of electricity consumption data for that site. So that's what's in the grey line there. The grey bars represent the monthly energy consumption across that site. And the blue line, had they not undertaken any improvement, is where that would have continued to track. So that's the forecast consumption prior to the installation. As I say, the installation occurred in August 2019. And what happened to the energy consumption of that site after that? Well, in August it went down a bit. September it continued as we completed the development of that installation. And in subsequent months, we were able to see and verify a significant reduction in the energy consumption of that building. So starting from a theoretical model, using the digital twin represented by SBEM, we were able to generate and confirm savings of 36% energy and carbon over the 6 months following that installation. Example case number one. Now, case number two is slightly different. Case number two is a large London office block. Again, commercial reasons, I can't describe it exactly, but this is an anonymized example. Again, a real building. Now, we had the EPC and we modeled it, and they were able to make a smaller set of improvements. The building had already been upgraded significantly over the previous few years, so there was a smaller percentage improvement as a result of those capital investment energy efficiency measures. But what we were able to do is to model the load shape. Now, the building actually, the owner-occupier, doesn't occupy the whole building. So they have multi-let elements. There are some other tenants within the building. And we actually had a total of 5 energy supply meters to the building. Aggregating those and analyzing them using our platform Arbon Insight, we've been able to benchmark that against the typical use cases of the various zones within the building. And what you're seeing here, the bluish line represents their load shape profile on a typical working day over a period of time, analyzed from 2018 data. The benchmark in grey represents not quite best in class, but certainly median best in class for the use cases represented. And what we're able to identify from that is a significantly higher energy intensity, both in terms of the baseline and the peak load. And that enables us to start to focus on where behavioral change and operational energy use can be enhanced in this building. So working with the on-site building manager, over the course of 2019, there were a range of things that we were able to discuss, advise, and that they were then able to undertake. So a nighttime audit of power usage. Fairly simple, relatively low cost. Let's find out where the power is being consumed when there's nobody supposed to be in the building. Threw up all sorts of interesting things. So we looked at the HVAC fans and the control of those. Actually, over the course of 2019, they were able to install some VSDs on some of the air handling units. Looking at the BMS settings, there was some fascinating variations there across the building within the BMS settings, and some improvements that were able to be installed. We looked at the plug loads. We particularly looked at lights left on. That's a visual impact, very easy to detect, and something that lots of people can contribute to on the journey. We actually managed to remove some redundant servers from site, which had a significant improvement. They managed to move some of their data storage and processing off-site into cloud-based and actually remove those servers from site, which helps the nighttime load. We installed some master switches in some of the common open plan office areas, so last person out, click a switch, and everything goes down to the base load. And finally, they were able to replace an old and inefficient electric immersion heating with some point-of-use hot water systems in the toilets. Over the course of 2019, so we've now got a fresh analysis from January, you can see that the actual profile has come right down to match the best-in-class benchmark type profile. And actually, we've been able to beat that in some areas. Overall, that's purely behavioral stuff with some capital investment. That has resulted in a carbon and energy reduction of 23%. Now, the return on investment I haven't got calculated because the costs associated were staggered over a period of time, and there were lots of things, lots of individual measures that contributed to that. But I hope you can see from the example, in terms of energy modeling, the combination of the energy efficiency from a digital model of the building, which delivered a 36% saving on one building. I realize there's a different building. Operational behavior, we've then got 23% from there. There is a significant impact on the operational energy use and the carbon intensity of these buildings using these techniques. What next? Let's see where we go from there. So this office building, the next step that they're looking to do is to install sensors on the internal environment. Now, if you bear in mind that a large percentage, 80–90% of the energy consumed in a building is for space conditioning, light, heat, and cooling for the benefit of the people operating in the building. If those people are not happy and comfortable, they are likely to be unproductive. So we're spending all of this energy. Let's make sure that the way that we're utilizing that energy actually optimizes the conditions for the people within the building. If they are happy and comfortable, they are far more likely to be more productive. So by analyzing this environment throughout the building, allowing the people to engage with how they're experiencing the environment, we can then also make further energy reductions. There may well be areas of this building where we're investing in heating and cooling and lighting that is not ideal for the people, or indeed that they're not in it at the time. So there are all sorts of savings that we anticipate being able to drive by analyzing the actual environment within the building. So my final slide, I was told to wrap up in 15 if I could, and I think I've probably achieved that. So these two tools that I've demonstrated on case study 1 and case study 2 are actually steps 1 and 2 of what can be viewed as a 3-step journey towards net zero. Now, if we've got to reduce, I was going to try and remember your statistic. We've got to reduce energy consumption in commercial buildings to 0 by 2050. We really need to act on the million buildings that have already been built, rather than just the buildings that are going to be built between now and 2050. That becomes a decreasing contribution to our net zero target by 2050 if we don't deal with the retrofit. So we have to do it. And we've got 1 million EPCs, so let's start from those. So we can model those. That's the identify on there. In urban estates, we can model those and we can identify those energy efficiency improvements on the existing built stock. Step 2, analyze. Let's stop wasting energy and leaving stuff on when we don't need it. Let's look at where those operational behaviors can be reduced to better than the benchmark or the median and actually eliminate wasted energy within the built environment. And finally, let's see where we have scope to deliver the remaining energy that we need to heat and power our buildings from zero carbon sources. I think we'll need far more than Carl's graph showed. I don't think we'll be able to reduce our energy consumption by the proportion that you represented, but I think there is scope to generate far more energy and heat that we need from low carbon sources. And that is what Urban Renew can do. So, thank you for your attention. I've wrapped up in short time, so I'll hand you back to Carl and look forward to further conversation. Thank you very much.
Thank you, Stephen. I think that was really fascinating how you've taken the SBEM model, mapped on top of it the consumption usage to actually create quite an intelligent tool for driving down energy use, and we've already achieved that in a few projects. That's fantastic to see. Next, I'd like to invite up Dr. Robert Cohen, who's Technical Director at Verco, who'll be talking to us about developing methodologies for a deep renovation protocol based on lessons learned from a European research project. Robert?
Thank you. Good day, everybody. Thanks for coming. I'm going to talk about a Horizon 2020 European project which is drawing to a close, possibly one of the last that UK companies have been allowed to participate in after Brexit. The key part of the project was to look at deep retrofit in non-domestic buildings, and we're focusing on offices and hotels. Now, the last two speakers have explained that what we're looking for here is real savings. We are not wanting to rely on theoretical savings, and the performance gap is well known and has to be avoided. So the key objectives of our approach have been to make performance verifiable, produce a verification plan, place energy meters in the right locations to verify predictions, and when we're looking at the performance gap, adjust boundary conditions in our model so that we are able to make like-for-like comparisons between predicted and measured energy use. And lastly, and importantly, instilling this relentless emphasis on achieving your energy performance outcome, without which you're quite likely doomed to fail. So we've looked at the deep renovation journey, and as a European project, we've identified 5 stages, which are on the left-hand side, making your decisions about what to do, doing your design, more detailed design, the actual works, and then the in-use stage. The next column from the left shows what is normally done across Europe, but also in this country. We have an EPC for the existing building, we get an EPC for the retrofitted building when it's designed, and we should get an EPC for the retrofitted building when it is completed, and that is the end of the day. We do not go on to measure performance. And there is a huge performance gap. So what this protocol does is introduce the real performance of the building, first at the design stage by doing an energy audit of the existing building and understanding how the model of the building can be calibrated to match with the actual performance. And then at the end of the process, once the building's used in operation, verifying that the actual performance is as predicted by the model. So the protocol has actions at the 5 different stages of the journey. To start with, it's really important to get stakeholder commitment, to understand the type of model you can do which is capable of simulation to the necessary detail, the energy audit of the existing building, and then you move on when you're developing your design, using the calibrated model, agreeing what the improvement should be, dynamic modeling, including of HVAC plant, making sure your controls are clear in the design stage, and the last point there is getting a design review. And this is something that we found is really important in making sure that the design is fit for purpose. So the detailed design has to include generating this validation plan, making sure the metering is in the right place. Once the work start, defend against value engineering, very careful handover and commissioning, and not to forget intensive fine-tuning once the building starts operation. And then in use, tracking the actual performance against predicted performance and making sure that any deviations between design and prediction are dealt with by remedial measures. So I've tried to put a strong emphasis on how modeling can help. I think the previous speaker illustrated that was also the case for him. in my view, the modelling needs to take a step up from what is required by the SBEM model. We need to start modelling on a hourly or less time step, not just at a monthly level. We need to be modelling details of the HVAC plant, certainly for air-conditioned buildings. So we need to simulate our building in a way that allows us to verify that the real building is performing exactly in the model. And that means the model has to have sufficient granularity that you can tell where real building deviates from design building. We need to get the controls right, and we should be able to define the controls at the design stage before they're installed, and then make sure that when they're installed, they actually work according to the design. To build the retrofit has to be in compliance with the model. Whoops, I pressed the wrong button there. Once the building's in operation, make sure the controls really are doing what they're supposed to. The comparison of actual with predicted targets can be done at a sub-meter level. Diagnose improvements according to those differences, and don't forget the feedback at the end, because this is a way of upskilling the whole industry to understand what actually worked well in your design, what didn't work well. And this is just a slide to emphasize that detailed simulation really can make a big difference between getting a small performance gap and getting a large performance gap. What are the key purposes of doing this modeling? And obviously we want to check that according to our design we will achieve our ambitious targets. Now, we're talking about a 60% reduction in overall energy use, which is what the first speaker said. We actually need to confirm that's possible through the design and then verify it in operation. If we want to improve performance, we have to target performance, not compliance. So another benefit of more detailed modeling is to optimize the size of plant in the building. And right-sizing plant can lead to dramatic improvements or reductions in plant capacity. And that will obviously save money. It will save embodied carbon, not just in the plant, but also in the things that connect plant, like ducts and copper pipes, copper wires. The reason that we have so much contingency in design work these days is because we have such low quality modeling that it doesn't give confidence to the designers to cut back on the contingency in plant sizes. The model also helps defend the design against cuts at the construction stage, where the contractor says, I can substitute this plant for that plant, and you can test that in the model and actually tell the client, well, if you do that, you're really going to miss your target. And it also helps prevent tenants in a multi-let office where they are responsible for their fit-outs, doing things in the fit-out which compromise the design targets. And again, the model can support commissioning and tuning up of the building. If you know how much energy is supposed to be used by a specific sub-meter over a month at a particular time of year, and that amount of energy in practice is well above what it should be, that is a very big signpost to looking at what is going on, because the model is good enough to predict exactly how much energy that sub-meter should be showing. And again, I come back to this point. If we want to improve performance, we have to measure performance, and that's something that's lacking a lot in current practice. So the design review, I've mentioned earlier, is a really important part of making sure designs are fit for purpose. Very special people qualified to do the review. This isn't just your mate. Somebody who understands HVAC design packages, understands good quality simulation, understands how to tune up buildings, understands how to go into existing buildings and do energy audits to improve them. And this will identify the risks in your design that you won't achieve your target. And it will review a full design package and a detailed simulation report. And it has a really important role, not just to get that building's design up to the level it needs to be to satisfy the client, but also for upskilling the market more generally. And it's a way of disseminating good practice or best practice around the industry. So intensive tuning and commissioning, this is quite a busy slide. It's getting your BMS to be working correctly, independent commissioning agent getting their commissioning right. Deep dives into the BMS to make sure it's actually doing what it's supposed to. That takes quite a lot of skill, another bit of upskilling we need in the industry. Documentation of plant. You go on site, you find that the labels on plant have no resemblance to the labels in your design drawings, and this just makes the whole process less efficient and full of friction. Managing agents and their FM teams need to be upskilled to actually have performance as part of their duties. Validation plan we've talked about. Performance-based maintenance is a good way of getting managing agents to perform. Delineation between those actors in the building, between the owner and landlord of the building, who can take responsibility for what we call the base building, the HVAC throughout the building and the common parts, and the tenants. So the tenants have only responsibility for what goes on in their tenancies. Those two different actors have to have information which speaks to them, and hand over and making sure that people have access to the meter data in a very smooth way. So there's a lot to get right there, and we have developed, as part of this European project, a protocol which both tells you what to do at each stage of the journey and allows you to collect the data which will enable you to verify the performance once the building's in operation. And we've proposed a way of categorizing whether a building has a verified performance compared with its design. This looks at all the main energy end uses and says, does the actual performance come within 25% of the predicted performance on each end use? So we've applied this protocol in case studies across Europe. We've had 3 in this country, and I'll just give you some key lessons that have come out of the studies. There's 4 of them here. The first one is that conventional modeling is just not good enough. Sub-metering is not good enough. Basically, people spend their money on sub-metering, but it doesn't work, and it's not usable. Buildings are not controlled as they're designed to, and that's something I've talked about, how you get that right. And lastly, the design industry is fixated on performance outcomes according to things like the EPC. And when you tell them that that's not going to work, they still refuse to change the design because it won't affect the EPC. It makes it more likely that it will improve the operational performance, but it doesn't affect the EPC. That's a failing, if you like, both in the EPC methodology, but also in designers walking away from the job after they've handed the building over, not looking at whether it actually performs as it's supposed to. So to wrap up, the final word is this is an EU-wide initiative. It's looking at how do you verify that buildings are performing as they're designed to perform, and it's looking particularly at deep retrofit of offices and hotels, and making the point that if your office or hotel performs in reality as it's supposed to, it will add value to the hotel or the office, and that will justify the extra cost of doing a deep retrofit. And that is a circle that we have to get to work. how do we get people to go for a 60% reduction in energy use when the apparent financial cost might not look worthwhile? The answer is, by doing that retrofit, you will create a higher value building. Thank you for listening.
Thanks, Robert. Really inspirational case study there. I really like the slide about the feedback loop, because we really need to grow knowledge and capacity in the industry. And if we aren't completing that feedback loop from design all the way through to actual in-use performance, then that knowledge is going to be lost and it's not going to continue to the next project. So great insights there. Moving on to our next speaker. So Professor John French is the Executive Director at the Cambridge Institute for Sustainable Leadership, and he's going to be talking to us about a case study in refurbishing a former telephone exchange. Thanks, John.
Good afternoon, everybody. Really nice to be here. I'm going to talk about a couple of case studies which basically address not only zero carbon, embodied carbon, but also getting to zero carbon in retrofit, because it's a very challenging area for us. So a few words about what I do. The Institute for Sustainability Leadership is promoting sustainability across all sectors, and including the corporate sector, the SME sector, and applied research. You can look at the detail of these slides later, but this is our kind of boilerplate which describes what we do. We are very interested in the key challenges around the built environment. For me, these are, how do you actually get to absolute zero carbon? Let's just put net zero to one side for a minute. Let's talk about absolute zero. What is offsetting? What is it really going to look like? Most offsetting schemes are highly problematic at the moment. So at a university level, we're very concerned about the lack of data to support good offsetting. Campus adaptation in universities, hugely challenging. I'm on the EAUC board, and one of the things universities are struggling with is how to adapt their campuses. Retrofit challenge is massive. Universities, of course, can help by providing leadership in this area, and they can take more risks than many commercial companies can. We need to look at the benefits. We need to spell these out in more detail, and we need to get more innovation across the table. All of this has to be accelerated and financed. I'm running a project at the university called Innovate to Adapt, and this is essentially about levering innovation from the university sector to address this adaptation challenge. And SMEs are really important in generating agile solutions to this. So we need the best researchers, the best technology transfer. We need to deploy everything we have to this challenge. The goals, the SDGs, I'm assuming you all know what the SDGs are. If you don't, or if you don't have a favorite SDG, look them up. I won't go into them in detail. But it's not just about environmental performance and carbon. It's about wider sustainability and everything that goes with that. It's covering, plastics and atmosphere and water and so on. But, let's look. We haven't really progressed much since the IPCC report of October 2018. We've been talking about it a lot, but we haven't actually been doing very much in practice. And here's the University of East Anglia. That's the Lasdon Wall at UEA, due for a major refurbishment imminently. Thermal camera shows how it's hemorrhaging heat. That is true of most universities in Britain at the moment. And the Enterprise Centre project that I was responsible for at UEA has become quite an iconic project with over 30 national awards because it is both passive house but also an exemplar of embodied energy through natural materials. Now that was a kind of testbed project to see how far you could get with new build. As the client-side director, I was determined to get natural materials in, and if you look at the forestry map of East Anglia, we have Thetford Forest, which of course is hardly ever used in construction. So levering our assets is important, but as client-side lead, I set a specification for that project. And let's just quickly run through that. 100-year design life, including adaptation for climate change, passive house certification, BREEAM outstanding, low embodied energy and high sequestered carbon, focus on supply chains, local supply chains ideally, biorenewable materials, soft landings. Take note of the last speaker, post-occupancy evaluation, absolutely critical. There's no point designing to this standard if you can't monitor it afterwards. And using all of that to educate SMEs in this space. I think, we achieved most of those with this project, and the Passive House standard gave us a discipline around energy reduction. I would recommend, if you haven't already done a Passive House project, to look at doing one, because the energy demand is so stringent, it forces you to be ultra efficient with your building. It also forces you to look at every aspect of deep retrofit when you're looking at old buildings. Of course, it means, super insulated, minimized thermal bridging, extremely airtight, mechanical ventilation, heat recovery normally is the system used, triple glazed windows and high thermal comfort. Now, Wolfgang Feist, I worked with him on this project, hugely beneficial in terms of an influence on my thinking on architectural projects. But if you look at the University of East Anglia, as a campus, it has incrementally improved its energy performance on its buildings. And you can see there, from the Sainsbury Centre, the Elizabeth Fry building, which was a case study back in the 90s of one of Britain's best buildings, then the Zeiser building, Julian Study Centre, then the Enterprise Centre, incrementally, building by building, energy consumption going down. What we need to do, though, is get to the point where they're below the line or equal to the line. We need to get right there, and we're not there yet. So there's the data. You can pull the data off the slides later. Embodied carbon. The Enterprise Centre got to 400 kilograms of CO2 per square metre over a 100-year life. So this is, you can see from the left bar, the concrete foundations push up your embodied carbon impact. If you're using natural materials, you're getting below the line rather than above the line. Please, we need to talk more about embodied carbon. It's really critical to the zero carbon challenge. So lots of publicity on that project. Now, University of Cambridge, of course, has now officially announced it wants to get to absolute zero by 2048. And it wants a steep 75% increase on 2015 emissions by 2030. This is not a trivial challenge for a university like Cambridge, which has got an enormous estate. And in order to do this, we have adopted science-based targets. And I'm not going to talk about those in detail, but I would simply say go and look up science-based targets, have a look at what they involve, because there's no offsetting in science-based targets. It's all based on absolute performance, absolute emissions, and it's very scientifically driven. And of course, being a research-intensive university, we would want to validate our research data. Right, here we go. So the project I'm working on at the moment, which is the thing you want to hear about, is the deep retrofit of 1 Regent Street in Cambridge. This is an old telephone exchange. We're looking at our inputs and our outputs. This is quite a difficult project because it's in a conservation area in the centre of Cambridge. This is the worst possible starting point for any retrofit because it is a brick-built building and has never had any insulation in its life. I've set a fairly demanding performance specification for it. There it is. You can see, we'll see what we're trying to achieve there in terms of internal comfort and performance of the building. But very much the same criteria as in the new build project I did, but this time, how hard is it to get to those same standards in retrofit? And if we start at the bottom this time rather than the top, we've gone for the WELL standard. We've said it needs to demonstrate 50 innovations. That can be design, it can be materials, it can be technology. It needs to be an exemplar of the circular economy. That means don't rip out all the mechanical ducts. Let's use them again. Let's use whatever we can in this building again and not send it to landfill. That is the hardest thing of all because the industry is obsessed with throwing away and refitting. If you look at refits of office blocks in London, most of it's going in the skip. Soft landings, 3-year post-occupancy evaluation, I think that's a given. Again, biorenewable materials, we want the whole biophilic thing. Of course, when I first did the Enterprise Centre, biophilic as a word didn't exist. And of course, carbon sink, BREEAM outstanding, passive house, but we're going for the ENERFIT standard for retrofit. And again, 100-year design life. So I'm wanting this methodology to start to become established. And we're now looking at a whole range of new projects across Cambridge to this standard. We're currently tracking our performance for all our materials so we can see what the embodied carbon impact is. And we can already see some quite negative data coming forward in this analysis around fit out and carpets on our embodied carbon assessment. Of course, we're going to dramatically change the look of this building. It's going to go from a building which is neoclassical with sash windows. We can't get to passive house standard if we leave those windows in. The right-hand image is what it will be. Of course, this has resulted in me having to take this project through planning committee, where it was recommended for rejection by the city council planners. He said, you can't possibly do that to a city centre building in Cambridge. So I said, well, I can. But this is really interesting because they recommended rejection. And so we said, well, no, we want it called to committee, please. We want it, this is really important for climate change, that we have this discussion now. And we took it into committee and we took it to a vote. And the councillors voted in favour of the climate change approach and adapting this building to the ultra-deep retrofit that we're doing. I think it will turn out to be a landmark case in planning because there's actually no guidance for planning officers at the moment as to how to evaluate recommendations for building improvement that address climate change. There's no policy guidance for them, so they don't actually know how to advise planning committees. So they acknowledged that, but they said, on balance, we think climate change is more important than the small amount of damage this will do to a conservation area. But it became a very, very subjective analysis in the end. We did model 5 different types of window and all the energy, operational energy and embodied energy assessment for every single window type. And we knew how many tons of carbon each window took and would deliver over 100 years. So there we go, that's what we're trying to achieve. And these graphs are really important because clients like universities are more interested in cost than they are in carbon, and we have to switch that, get them more interested in carbon than cost. The red lines, that's over 15 years. I'm sorry the graph is so small, but over 15 years, the cost of electricity in this building, cumulatively, if we were to do nothing now, is over 1.4 million pounds of electricity costs based on today's electricity costs. If you do a Part L standard retrofit, that comes down to just over 1 million over 15 years. And if you do a passive house deep retrofit, you can see the green graph, that's £200,000. That is a very powerful argument. And when you think that most universities only model their energy costs over the next 2 years because they can't work out the impact of energy security or decarbonising the supply chain on energy costs, they don't know what that will be, you can see that the impact is going to be much bigger than that over the forthcoming period. Risk, must not neglect risk. Any of you who've been involved in ultra-deep retrofit buildings or new zero-carbon buildings, the biggest challenge you face is contractor-based risk and value engineering. You'll get all the way through to the end of REBA Stage 4. You have it beautifully designed, and then the commercial negotiations come along and strip out all your fantastic outputs that you want. You have to fight like hell to keep them in. And then you have problems with planning discharge, and then when you almost finish the project, you have problems with early warnings on site, which again threaten the project. And one of the things that people like me have to do most is to demonstrate projects like this can be delivered at the same price as a normal building. They're not vanity projects, they don't cost the earth, they are achievable, the client can deliver it. So at the moment, the Regent Street project is on target to be the same price as a normal University of Cambridge refit, fingers crossed. But we're about to enter commercial negotiations. Now, I just want to quickly, I'll need to wind up in a minute, I'll need to quickly just talk about my wish list of the things I think I'd need all the companies in this enormous conference room to help me with to get to deep retrofit. Just a quick snapshot. If we are going to get buildings to zero carbon, we need better on-site generation of power, whether that's solar or other forms of renewable power generation. We're not generating enough from buildings to get the balance between consumption and production balanced out. Solar panels and British climate are only producing a very small contribution towards our energy. We need to avoid steel and concrete in our structures. We need more investment and research and development into mechanisms to sequester carbon into building structures. And we need the modelling to enable us to do that more effectively for retrofit, that gives more credit to the existing structure that is already there. We need much better insulation technologies. We need to look at airflow technologies around double glazing and triple glazing. You know, why are we over-engineering buildings with historic legacy with triple glazed windows? We need to look at more advanced systems. We need to think about buildings actively removing CO2 from the atmosphere as part of their design. That's quite radical, but we've got all these biotechnologists out there. We ought to be able to do it. And I think scope better risk management systems to allow more pioneers to do renewable buildings at deep retrofit so that they don't actually run into problems which strip out the functionality of their buildings. I could go on, but I won't. But anyway, so one of the things we're doing is using our convening power as a university to generate this discussion. And we would like to see more case studies where we can evaluate the actual performance of deep retrofitted buildings against their original design brief. Okay, I'll stop at that point. Thank you very much.
Thank you, John. Right, so you had a wish list there, which you said was short, but it's actually quite long. So there's a lot for us to do as an industry. We have 10 minutes left in the session, so I'd like to throw to you all for your questions. I guess just to get warm things up, John, you touched on the point around embodied carbon and operational carbon. How did you reconcile that with your project? So I saw a model for, looked like a whole life carbon model or something like that. How did you reconcile some of the operational carbon improvements versus the embodied carbon upfront additionalities?
What we've done is we've tried to put a limit on the amount of carbon we spend actually retrofitting the building. That means that everything we put into the building, furniture, fixtures, carpets, we are costing that carbon. And we are wanting any materials to last as long as possible. So the number of times you replace them, of course, pushes your embodied carbon up. And then we're looking to switch, wherever possible, to materials that trap carbon as opposed to don't trap carbon. So it's carbon budgeting, really. At the moment, we haven't seen a conflict with getting our operational carbon down as well. We think both are achievable simultaneously if you build it into the early design work. It's all about getting the designers to think about both things at the beginning. Because in my view, there's no point building a fantastically low energy building if it's full of plastic, polystyrene, concrete and glass, and its embodied carbon impact is huge in terms of the CO2 you've emitted actually creating it. And then you've also got to think about, at the end of life, how you take it down, what you do with it, where the materials go to. Again, you don't want to create something that's going to be an absolute liability in carbon terms at the end of life. So that's something we tend not to think about with buildings as end-of-life cost.
Great, taking that whole life perspective rather than just thinking about the shorter gains. Question over here.
No worries. A question for John as well. John, through your work with University of Cambridge or any of the other universities that you're working with, I'm not sure if you mentioned it, but have any of them made an explicit commitment to net zero yet? And if they have, are they going to report on their performance as they get there to someone else, not themselves?
Yeah, so the Environmental Association of Universities and Colleges, I mentioned EAUC, it has a thing called the SDG Accord, Sustainable Development Goal Accord. So you can go to the website, you can sign up, and then you can self-monitor and report your university's performance against the SDGs. So that's the first thing that's happened. There's also a climate commission that universities have created so that they are actively promoting new ways of looking at getting to zero. The universities have taken lots of different approaches. There's not one approach. Scotland is the most advanced, where the Scottish Funding Council has actually set targets for universities in their funding agreement. So if you're in a Scottish university, you actually have to report on your carbon savings back to the Scottish government. That was a really interesting development where our Climate Change Committee in the UK helped develop policy for the Scottish Parliament to implement, but that's the only part of Britain where that's happened. So it's quite variable. Some universities have set absolute targets, some have set zero targets, some haven't set targets yet.
Thanks, John. I think there was a question in the middle there.
Yeah, Simon Webb from Nichols Group. We do major infrastructure projects. Could the panel talk about what sort of people you think are going to produce the sort of innovation that you've been talking about? I mean, I've been hearing some exciting stuff about sequestering carbon, major changes in attitude on the part of construction companies and so on. Apart from Cambridge graduates, who are obviously going to play a major role in this, what sort of folks do you think are going to be the areas where innovation could be looked for to be put into these big new enterprises? Thank you.
Well, if I could comment, and I mean, from the point of view that all of the largest major companies are starting to declare a carbon reduction target. So I mean, Microsoft have said that they're going to be carbon neutral by, I can't remember the date, 2035, and then negative after that, so as to recover all of their carbon since their inception. But all of the major UK commercial real estate properties have declared a target for net zero. Now, it's not about being dramatically innovative. We actually know a lot of the solutions that need to be implemented already. It's about reducing our consumption, implementing energy efficiency, those behavioral changes. If a lot of those not terribly innovative things, we make a huge impact. Yes, we need to do some of the deep dive retrofit. Yes, we need to do passive level deep retrofit on a lot of property, and we need those exemplar projects to understand the state of the possible. But we actually also need to do an awful lot of known tech applications on existing buildings. So we need to come up with the resource and the investment to do so and get on with it. So a lot of it is just about getting on with it rather than who's going to do the really clever biosequestration.
Go ahead, Robert.
Yeah, I'd like to echo the emphasis on doing the simple things well, which we don't do at the moment. We've looked at the office sector in Australia, where they've had extreme success in driving down the energy, driving down the energy use, driving up the energy efficiency of their offices, and this has been driven by a market where energy performance is recognised as a value generator. And this is what I was saying in my talk, that you need to associate a better performing building with a better value building, because that will then drive the real estate sector to prioritise the performance of their buildings. And if I may say so without upsetting any of my clients in the audience, we are given an absurdly small amount of resource to manage the assets that they currently have, of the order of 1 hour per year per asset, to make sure it's energy efficient. So that has to change if we're going to get their buildings working efficiently.
Specifically in relation to the skill set, the knowledge base for this, I can speak with some passion, because most of the colleges in my university are currently struggling to get the kind of inputs they need from the consultancy community around energy engineering, energy profiling, reduction scenarios. Now, obviously, the companies here, some good introductions will happen after this meeting, I've no doubt. But you find that the aggregated skill set in the commercial sector at the moment, together, collectively, whether you're looking at architects, energy engineers, building designers, is not where we would want it to be to deliver these sorts of projects. So the question you've got to answer then is, where do you get that capability from? Do you import it? Do you grow it? Do we have to introduce new postgraduate courses to get people lined up? Because it's the holistic thinking that matters. One of the real challenges is that we've got so many different standards in the built environment sector. We've got BREEAM, we've got LEED, we've got WELL, we've got Passive House. None of them on an integrated basis really deliver what we want to get to absolute zero in the building stock. So I think we do need to re-engineer that, and we need to look at the skill base to deliver it.
Thank you, John. Okay, we'll have time for one last
Hi,
question.
my frustration as somebody who is fortunate enough to own some offices with various tenants is the education of the tenants. You know, we've got to make such massive, dramatic changes in such a short space of time. I think the first route into that is to get people to turn the temperature down on their air conditioning, for instance. I find it hugely frustrating when I turn up to my offices, as I have done recently, and staff are outside with the door wide open so that they can get the benefit of the heat coming out. I go into offices where the air conditioning is set at 25 degrees when, you know, most people would say 21 degrees is sufficient. If you address that first, there would be a monumental reduction in carbon output, wastage, I would say. And I would have thought, as an emergency measure, one thing that the government could introduce some legislation in that respect, because, you know, I guess it's like you can't force people to do that as a landlord.
Robert, you want to comment back?
The government's listening. They're consulting this summer on introducing mandatory performance measurements in non-domestic buildings, and they'll announce that the plan at COP26. And I think the transparency and disclosure that will come from that will answer a lot of the points that you're bringing up.
But my problem is that as a landlord, I can't force them to turn the temperature down. I have to provide air conditioning. Well, I don't have to, but it's part of the developments. It heats, it cools. It's up to the tenants to operate the heating and cooling. It's their responsibility, and it needs to be imposed on them, not the landlords.
That's an interesting perspective. The success they've had in Australia has been largely driven by the asset value argument, but also by the landlord taking control of the building. So the tenants are expecting the landlord to control the building, and they do not expect the landlord to delegate that responsibility to the tenants.
And that tool, Robert,
I can't sit there over the switch of an air conditioning unit in however many thousands of square feet with various tenants and so on. It's a ridiculous proposition. It's got to be the tenant that has to take responsibility. What do I walk around with a thermometer every day?
Can I just comment? Presumably you've got sub-metering in place with your tenants, so you've got that aspect. And then it's education, I think, leadership. Get them together, give them some seminars on behaviour change. Passive house buildings suddenly don't work unless you prepare people and you have a soft landings process before you get into the space about how you should be using it. Everybody has to know how to use these environmental buildings, otherwise they don't work.
We're actually over time now, but I see a very eager hand up there, so maybe that'll be the last question before I ask the speakers maybe to hang around near the front.
Sure. Up here? All right. So I worked in the industry as a sustainability consultant for one of the big consultancies. Just to add to John's comment about the professionals, it's absolutely right. You know, when you're working for a large team of engineers and specialists, they are very risk averse, and they work in their silos. You know, they got their liabilities and also, you know, all sorts. So they're their own scopes, and clearly the profit margins are very, very important. So if you don't have the client on board, so I worked on lots of university projects, you know, like BREEAM Excellence and all that. If you don't have clients, not just initial commitment, you know, like they set all these wonderful targets, but the projects last for like 5 years or whatever. If you don't have them persistently on board, what you're trying to do as a sustainability consultant, you're kind of further down in that chain, so you're tearing your hair out. You're like, you know, like you're trying to move mountains. But as soon as your client comes on board, all that power dynamic changes. You know, so it's very important to get that commitment from the client. And just to flip that argument that gentleman made over there, last year I worked as an ESOS assessor for a number of buildings and businesses. So what the tenant says, you know, when they are leasing the buildings, they said exactly the other way around. You know, they said the landlord's not hearing them, you know, their hands are tied. the equipment is inefficient, you know, the building performances, the thermal performance is appalling, but landlords just don't commit to making big changes. So there is that flip side of the argument as well. All right.
Have I got time to answer that quickly? Can I just say one point, which is risk and innovation are diametrically opposed. So if you take sustainable buildings are risky things for the client. So one of the biggest challenges with projects like this is that at REBA stage 1, a cost consultant will come in and say, you're doing all those performance enhancements, it's going to cost the earth, and they will instantly put the client off taking those risks. So what you have to do is that on the client side lead is to interrogate how the costs have been built up and challenge right at the beginning. Otherwise you'll lose all your performance indicators at the first hurdle. But then you have to stay with it and make sure it doesn't creep in later. But it's all about risk and project management more than it is actually about materiality and technology.